Assalamualaikum. My name is Muhammad Shahir bin Jitsa. I'm from section 10, group 4. So this video is our group presentation for our group project with title Operation of Letter Machine, Mile Machine and Drill Machine. My group members is Muhammad Adri bin Muhammad Saad, number matric CD 190296, and Muhammad Amir Ashraf bin Rashidi, number matric AD 180206. So moving on to the introduction. Metal fabrication is a term referred to any process that cutting, shaping or molding metal material into a final product. For the specific name for the process, common metal fabrication process are casting, cutting, drawing, folding, forging, extrusion, machining, punching, shearing, stamping, and welding. Fabrication develops a final product from raw or semi-finished materials rather than assembling it from ready-made component. For this project, we are focusing more on machining process. What is machining? Machining is a controlled material removal technique that cuts a material, typically metal, to a specific final form and size. The example of metals that we use is like aluminium, brass, or maybe stainless steel, and more. The most common machining operation is turning and milling. But the other process are occasionally integrated into this process or are carried out on their own. For example, a drill bit. A drill bit can be mounted on a turning lathe or tossed into a drill press. There are 7 basic machine tools that involved in machining process. The first one is turning machines. Second is shapers and planers. Next, drilling machines, milling machines, grinding machines, power saws, and presses. But for this project, we are going to do for the lathe machine, drilling machine, and milling machine. Okay, moving on to the lathe machine. The lathe machine is a machine tool that removes extraneous metal from a workpiece to give it the correct form and size. Because of the two centers between which the job can be held and turned, the lathe machine is sometimes known as a center lathe. The main function of lathe machine is to remove excess material in the form of chips by rotating the workpiece against a stationary cutting tool. This is performed by securing and rigidly holding the work on the machine, then spinning it against a cutting tool that removes metal from the piece. To properly cut the material, the tool must be tougher than the workpiece material, be rigidly held on the machine, and be fed on or progress in a certain manner relative to the work. So for the milling machines are equipment that will use rotary cutters to remove material from a workpiece. These devices are capable of drilling, boring, and cutting a wide range of materials. Milling is the process of removing chunks of material along a line with the tool axis, and milling machines are the tools utilized in the process. Milling machine exists in a number of shapes and sizes. There's a lot, and they are utilized in a wide range of sectors. Milling machines are used to produce similar results to lathe in many ways, but unlike lathes, which spin the workpiece, milling machine use a vise or fixture to hold the workpiece motionless. Milling machines remove material with cylindrical instruments like drills and mills. Milling machines are most commonly employed on flat surface, but they can also be utilized on irregular surface. The next one is a drilling machine. A drilling machine, also known as a drill press, which is a machine which is a powerful tool that turns advanced rotating drill bits into a workpiece to create a circular hole into or through metal, plastic, wood, or other solid materials. A chuck holds this drilling cutting tool in the drill press and it is fed into the job at various rate. For the desired final item, the speed and feed must be appropriately set and the coolant must be provided. Not only can the drilling machine be used for drilling, but it can also be used for a variety of other machine tasks. So, I'm going to present for milling machine. This is the specification of milling machine. The model, table dimension, travel, spindle speed rate, feed rate, spindle rotation angle, motor output, ram travel, ram rotation angle, machine size, and machine load. This is specification of milling machine. So for this project, I'm going to use brass. What is brass is a versatile metal that is frequently used in plumbing system. It's also commonly utilized in musical instrument, as for example guitar, as well as cosmetics and home decor. This is due to its excellent workability and ability to obtain a high polish, which make it aesthetically beautiful. It is also inherently resistant to seawater corrosion and doesn't have any combustible quality. Okay. For this project, we are using a square brass plate, and we are going to make 4 holes at this brass plate. So for the operational steps, the milling machines involve the following process or phases of cutting, such as milling cutters, surface finish, and gang milling. So I think moving on to the flow chart. This is flow chart for the process. We start the program and we put the constant here, and this is for asking the question from the user, and this is the limit or condition. This is, or actually this is for yes, this is for no, and this is the process where the input will be used lah. And after the process settle, it will display this thing, display machining time, total energy consumption, solid waste generation volume, and estimated productivity per day. Okay, this is complete program codes, or we can use this. Okay, here this is the title and the constant, and for this we are going to ask the user for the length, the width, the height, radius for the hole, the distance between the holes, and the distance between the hole and the edge. So this is the process. And lastly the output, which is machining time, energy consumption, solid waste generation volume, productivity, and efficiency. So we are going to run the program. Sorry, it's a bit glitch. Okay, this is the program will looks like, and we're going to try some input. For example, the length is 10, the width is 6, the height is 3, radius of hole maybe around 2, distance between holes 1 and 1. So this is the output. We are going to get machining time 0.17 second, energy consumption 8 hours equal to 3 kilowatt. Solid waste generation volume is 37 kilogram. Productivity is 0. Efficiency is 5. So that's all for milling machines for the code part. So we are moving to calculation, formula and equation. Machining calculation for milling. For spindle speed n, this is the formula, n equal to V over pi d. V is cutting speed and D is cutter diameter. Next is feed rate. The formula is feed rate equals to N plus NT F N multiply with NT and multiply with F. N is this spindle speed, NT is number of teeth, and F is feet per tooth. Next is machining time. There's two formula. The first one is slab milling. For slab milling, the formula is Tm equals to L plus square root of D multiply with sum of diameter, cutter diameter, minus with depth of cut over with feed rate. Okay. The first milling is there's two formula. The first one is L plus D over Fr, which is length plus diameter over with feed rate, or the other one is L plus square root of W multiply with sum of D minus W over Fr, feed rate. And this is for material removal rate, MRR equals to W multiply with D multiply with Fr. This is some other formula that we can use for speed, feed rate, SFM, which means phase feet per minute. IPT means inches per tooth. MRR, AFPT means adjusted feet per tooth, and HP horsepower.
My name is Muhammad Miraj Rabi Rashidi, and I will talk about the drilling machine. So the model that I pick is LG25A. So we can see the max drilling capacity, spindle taper, spindle travel, spindle speed, number of speed, swing, column diameter, table diameter, base diameter, distance from spindle to table, distance from spindle to base, motor HP, horsepower, overall height, and weight. So we can see all the data in the table below. So the material that I picked for this part is aluminium. So aluminium is a silvery white lightweight metal. It is soft and malleable. Aluminium is used in a huge variety of products, including cans, foil kitchen utensil, window frames, beer cans, and aeroplane parts. This is because of its particular property. It has low density, is non-toxic, and has a high thermal conductivity. Has excellent corrosion resistance and can be easily cast, machined, and formed. It is also non-magnetic and non-sparking. It is the second most malleable metal and the sixth most ductile. It is often used as an alloy because aluminium itself is not particularly strong. Alloy with copper, manganese, magnesium, and silicon are lightweight but strong. They are very important in the construction of aeroplane and other form of transport. Aluminium is a good electrical conductor and is often used in electrical transmission lines. It is cheaper than copper and weight is almost twice as good as conductor. So the operational step for drilling is simple. First of all, we need to make sure that the tools and material is correct. You know, the the drill bit need to be right if you want to drill something, drill metal like aluminium. Second, preparation fast forward. We need to mark where you want to drill. Then you're going to make a center punch mark to help your drill bit safely to do its job. The third step is anatomy of a drill bit. Then load the drill bit in the drill press. You need to chuck the drill bit into the center between the chuck jaws and use the chuck key to tighten it. 5 center the bit, 6 clamp the work, and you can start drilling. So this is the flow chart. So you need to enter the input such as spindle speed, productivity, work, and then we need to calculate the consumption, machining time, cost, and solid weight, and then we can display. And this is the C codes. So we need to enter the spindle speed, productivity per day, float, energy of motor, total cost, 1 ringgit, and total energy consumption, waste, total operation cost. So we need to enter the parameter, enter the depth of hole, enter the thickness of steel in enter the radius, enter the weight. So then we make a assumption. If d is minus equal to 6, then this is the calculation. There are 3 assumption. D minus equal to 6, D minus equal to 12, D less than equal to 18. So if it is not meet the requirement, then we have to write the output object parameter does not meet allow object parameters. So this is the coding that I made. So we have to run it. So enter the depth of hole rim. So I'm gonna use 12 mm. Thickness, I'm gonna take 15, radius 13, and then the weight 1 kilogram. So using those data, we get the machining time is 17.77 second. The total energy consumption, estimated productivity per day, solid waste generated, total operation cost. So this is the coding. And for calculation formula and equation, we can, so the cutting speed formula is it is defined as the speed of the periphery of the cutting tool in meter per minute. So this is the formula. And second one is feet. The feet can be defined as the distance moved by each rotation of the drill bit into the workpiece. It is mostly measured in millimeter. The feet range varies from 0.05 to 0.35 millimeter. The amount of the metal removed is a function of the cutting speed and the feet. By using the highest possible feed rate, the best tool life for a given tool can be obtained. And the third one is machining time. So this is the formula: T divided by N times F, where N is the RPM of the drill, F is the feet per revolution of the drill, L is the length of the hole in mm, T is the drilling time in a minute. So yeah, that's all from me. Thank you.
Assalamualaikum warahmatullahi wabarakatuh. My name is Muhammad Adri bin Muhammad Saad. My matrix number CD190296. I will explain about lathe machine. Okay, for machine specification, center machine, swing over machine bed, minimum 350 mm. Swing over cross light, minimum 190 mm. Distance between center, DIN 806, MT3 750 until 800 mm. Turning length 700 to 750. Width of bed minimum 260 mm. Work spindle, spindle diameter in front bearing 60 mm. For spindle bore 35 mm. Taper bore DIN 228, shorten MT5. Normal chuck diameter 160 mm. Maximum diameter of face plate and clamping disc 315 mm. Tool slide, guide length of carriage 350 until 365. Graduation of longitude, scale on apron box, hand wheel 0.2 mm. Cross slide travel 175 until 190. Graduation of scale at cross slide spindle 0.025 mm. Width of cross slide 140. Compound slide travel minimum 100 mm. Graduation of scale on compound slide spindle 0.05 mm. Width of top slide minimum 110 mm. Tail stock with hand wheel, stroke of quill 100 until 120. Diameter of center sleeve 50 mm. Taper socket DIN 228 MT3. Scale graduation on center sleeve 1 mm. Scale ring at tail stock spindle 0.05 mm. For scale graduation, cross travel equal to 10 mm. Drive, number of speed range 2 times 8. Speed range A 50 until 350 rev per minute, 8 speed. Speed range B 250 until 2000 rev per minute, 8 speeds. Thread pitch with standard change gear set BS. Threads 4 until 76 TPI. All standard metric threads selectable except for 0.45 and 405 mm. 0.25 until 16 mm. 24 module pitches selectable except for 0.4 and 4.5 mm. 0.25 until 16 mm. Lead screw pitch 6 mm. Coolant tank with complete pump capacity 0 until 14 liters. Floor space required, length times width times height of machines. Work spindle above floor. Maximum 2000 times 1000 times 1400 mm. Equal to 1000 equal to 1000 until 1200 mm. Sound pressure level according to DIN 45,635 until 16 at 80 dB max. Okay, this is headstock selected part design. The main part of the lathe machine is headstock. It is usually located on the left side of the lathe, and it is a house of the driving mechanism and electrical mechanism of a machine tool. It is equipped with gear, spindle, chuck, gear speed control lever, and fed controller. The function of the headstocks holds the job on its spindle nose, having external screw threads, and internally more stepper for holding lathe center. It is rotating at the different speeds by cone pulley or all gear drive, where there is a hole throughout spindle for handling long bar work. Other than that, headstock transmits power from the spindles to fed rod, lead screw, and thread cutting mechanism. A few of accessories were included in the headstock, which is 3-jaw chuck, 4-jaw chuck, lathe center, and lathe dog, collet chuck, faceplate, and also magnetic chuck. A separate speed change gearbox is placed below the headstock to reduce the speed in order to have a different feed rates for threading and automatic lateral movement of the carriage. The fat rod is used for most turning operation, and the lead screw is used for threading cutting operations. For the operational steps, turning, the operation of reducing the diameter of a workpiece to produce a cone shape or a cylindrical surface. A simple single point cutting tools are used for turning operations. Turning can be different type like tapers and taper tuning, straight turning, and profiling, external grooving, and else. For tapers and taper tuning, a taper may be defined as a uniform increase or decrease in diameter of a piece of work measured along its length. In a lathe, taper turning means to produce a conical surface by gradual reduction in diameter from a cylindrical workpiece. Then the straight turning produce a cylindrical surface by removing excess metal from the workpiece. In the profiling, the cut can be vary with regard to cutting depth, feed, and speed. For external grooving, it is turning operation machines. The outer diameter of the workpiece. Facing, an operation of reducing the length of workpiece to produce a flat surface, square with axis. A regular turning tools may be using for facing a large workpiece. And drilling, an operation of producing a cylindrical hole in a workpiece by rotating cutting edge of the cutter known as the drill. Boring, the operation of enlarge a hole or cylindrical cavity to produce circular internal groove. Holes may be bore, straight, and tapered. They have counter boring and taper boring in this operation. Counter boring is the operation of enlarging a hole through a certain distance from one end instead of enlarging the whole drill surface. While the taper boring is similar to the external taper turning operation and is accomplished by rotating the work on chuck or a face plate and feeding the tools at an angle to the axis of rotation of the workpiece. What is called by reaming. Reaming is the operation to finishing and sizing a hole which has been previously drilled or bored. The tool used to call as a reamer which has multiple cutting edge. Curling. Curling is the process of embossing a diamond-shaped pattern on the surface of the workpiece. The purpose of knurling is to provide an effective gripping surface on a workpiece to prevent it from slipping when operated by hand. Chamfering, the operation of beveling the extreme end of workpiece. This is done to remove the burrs, to protect the end of the workpiece from being damaged and to have a better look. Filling. Filling is the finishing operation performed after turning. This is done in lathe to remove burrs, sharp corners, and feed marks on workpiece, and also to bring it to the size by removing very small amount of metal. The operation consists of passing a flat single cut file over the workpiece which revolves at high speed. Parting. Parting is the operation of cutting a workpiece after it has been machining to the desired size and shape. This process involves rotating the workpiece on the chuck or face plate at half at the speed that of turning and feeding by a narrow parting of tool perpendicular to axis by rotating the cross. Slide screw by hand. Threading. Threading is the operation to produce a helical groove on the cylindrical or conical surface by feeding the tool longitudinally when the job is revolved between center or by a chuck. Threads can be produced either on internal or external surface of the cylindrical bar. Grooving. What is grooving? Grooving is the process of reducing the diameter of a workpiece over a very narrow surface. It is often done at the end of the thread or adjacent to a shoulder to leave a small margin. Thus, grooving operation have square groove, round groove, and bevel groove. Forming. Forming is the process of turning a convex, concave, or of any irregular shape. Polishing. It is basically a surface finishing operation to improve the surface quality of the workpiece. Polishing will successive, successively finer grades of emery clothes after filling result in very smooth, bright surface. Okay, this is my programming flowchart. Start and then load the raw material, set offset or word coordinate, set tool geometry, run the program, rough cut, finishing cut, measure workpiece, to set tool wear and end. This is my complete program code, standard program code for late program from G code to C code. Okay, this is a calculation formula and equation for cutting speed. Cutting speed V equal to pi dn over 1000 m per minute, where D is the diameter of the work in mm, n the RPM of the work, and m per minute in meter per minute. Second, feet. The feet of the cutting tools in lathe work are the distance the tool advance for each revolution of work. A feet is expressed in millimeter per revolution. Number 3 is depth of cut. Depth of cuts, this is the formula. T equal to D1 minus D2 over 2, where the diameter 1 of the workpiece surface before machining, and D2 is the diameter of the machine surface. And number 4 is the machine time, where L over S time N minute, where L is the length of the job, S the feet of the job, and N the RPM of the work. Okay, that's all from me for the late programming. Thank you.
For the for the conclusion and limitation we face or problem we face in this project, we have understand about the conventional machine and its operation, such as lathe, mile, and drill. We also have developed 3 complete programs for each process and list out the complete steps or operations involved to fabricate the product for each process. Actually, there is a lot of limitation and problems we face by our team along the progress of the project, especially because of the online learning. All of us are never been able to see and know a lot about the machine we talk about in this project, and the only way to get an info is by using online information. Additionally, there is a lot of lacking in terms of communication between us because we are not at the same place while making this project, make it hard to make a decision or plan. Although we face many difficulties and obstacles, we still managed to finish our project before the deadline. This is the reference we use. So I think that's all for this video. Thank you.